Okay, so in today's problem, we're going to show that this random variable y is a Poisson distribution with a mean of alpha. This is the mean, and the probability that y equals 1 is 0.15, which is actually quite high, relatively speaking, considering that this can be any value at all, any integer, positive integer value. And so this also, the fact that it's 15%, if I recognize there could be more than 100 of them, this is actually contributing a fair bit. 1 is contributing a fair bit to the overall probability, which tells me that the mean is probably going to be in the vicinity of 1. Okay, so those are some background. Now, one of the things that I want to say is, like, a lot of the solutions in this textbook, you'll see they use the formula, I think it's something like lambda x to the minus lambda over x factorial, and this will give you the probability that x is equal to x when x is a Poisson random variable with a mean of lambda. Now, this formula here, you do not need to know this. This here is like was in the old math HL syllabus, which you needed this. And so many of these questions that you'll see have been like stolen from this syllabus. And so many of the solutions still use this, but you don't need to do that. There's other ways to do it. So don't feel like, oh, I don't know this formula, because you don't need to know it. Even like the people who make the solutions book to these scenarios, they are also like more traditional math people, and so they're going to go back to these formulas. But you can always use your calculator. And here's how we can do it for this problem here. So I'm going to show that there's two solutions. So the first one, I'm going to go to my calculator. I'm going to go, well, this is going to be 0.15. That's the probability. This is y1. I want to find, I'm going to make a curve of this. Now, if I go here, I'm going to go to my distributions, and I'm going to go Poisson PDF, because I want it exactly to be 1. And I'm going to make lambda x, because my mean can be any value I want. And my x value is going to be 1, because that's this value here. And I'm going to put that into, enter it in. And now I'm going to go to my window. Now I recognize that x is this mean value, and it's going to be close to 1 because this probability is relatively high. Okay, and so I'm going to start at 0 because I know it's and I'm going to go up to 5, and that should be sufficient because I know it's going to be close to 1. My y values are looking up probabilities, right? So I know it's got to be between 0 and 1, it has to be between. And then let's just graph it and see what we get. Well, we see we get these two, and so these are my 2 points. Okay, and so I can show that, and if I find the intersection, 1, 2, 3. Oh, too fast. Go find the intersection. 1, 2, 3. All right, here's the first value. This one here is 2.99 is equal to alpha. If I find the other one, 5, 1, 2, I'm going to go 0.1. I get this one here. Here is alpha is equal to 0.179. And so here are my 2 alpha values that I can get from my calculator. And the reason why so there are 2 possible solutions. There they are. Explain how the 2 solutions both apply correctly to the event. Well, here is the probability of 1. No, that's not true. Here is the value of 1. These are all probabilities. And so I know, because, as I was saying, this probability of it being 1 is relatively high, considering there's an infinite number of possibilities, the solutions are going to be near 1. And so this is as it's getting higher, the alpha value, and it's getting lower away from 1. This is getting closer to 1, further away from 1. I hope that helps.